Hey, this is Mr. Barr, and now we're going to do dilations or scaling. This is our final transformation that we're doing, and this is the only one that actually changes the size of an image or a shape. Our learning goal is I can manipulate shapes using transformations. Why? Because computers' graphics are just transformations, and I want to understand how software works. On your computer, you have the ability to zoom in and out. Have you ever thought about how your computer does this? Today, in a very simple way, you're going to learn how the zooming process works. A dilation is a transformation that produces an image that is the same shape as the original, but a different size. A dilation that creates a larger image is called an enlargement. A dilation that creates a smaller image is called a reduction. So when your pupil dilates, it actually gets bigger. So normally we think of dilation, when you think of it in the medical sense, it's getting bigger, it's opening up, but in math it can either be getting bigger or smaller. So dilation. So let's get that into our notes. And let's get our title first. Dilations or scaling. Start with your name. I still have my triangles from the last lesson. Okay, name. And our title is dilations. Not dilations. All right. And a dilation, it keeps the shape, it just makes it bigger or smaller. Dilation. It's the same shape. And I think we can do one in our notes. If we had this is a dilation. It's just zooming in or out, zooming in or out, zooming in and out. So really, here, I'm going to do a dilation right now. Watch the screen. Ready? That's a dilation. Notice it's not actually changing the shape. It's just making it bigger or smaller. That's a dilation. So how to dilate? You take each point and you multiply it by the dilation factor or the scale factor. We're going to get that into our notes also. How to dilate. Multiply each point by the dilation factor or scale factor. So here's how it works. If I have this point, we're going to dilate So we're going to dilate 3 comma 2. That's almost off. We're going to dilate 3 comma 2 by a factor. Let me put the word factor in there. By a factor of 3. So what I do is I have this point, I have this 3 comma 2, and I'm going to multiply each of those parts by that factor of 3. So this becomes 9 comma 6. Not too crazy on this one. Let's see if we got another one. And then after that, so we're going to dilate this by a factor of a half. So I just take each point, point by point, and I multiply it by the dilation factor. So let's do one more in our notes here. So you see point A. Where is point A? Point A is at negative 4, 4. We're going to dilate negative 4, 4 by a half. So I take half of this, which is negative 2, and half of that, which is 2. That's it. That's how I do a dilation. Now, I think that's it for the notes, but let's do some on paper. Not on paper, on the computer. So I'm going to dilate each of these points. So right here, I have a point at, let's see, this point right here is at negative 4, 4, right? Negative 4, 4. So cut each of those in half, it puts me at negative 2, 2, negative 2, 2, right there. There's A prime. I just dilated it. This is at 4, 4. So its new point is going to be at 2, 2. Cut this in half, right? This is at 4, negative 4, which is going to put me at 2, negative 2. And actually, once you get one of them, you can kind of build the rest off of it. There we go. We just dilated this by a factor of a half. Yep, there it is. We're going to dilate this by a factor of 2. So this is at 1, 1. That's 1, 1, which becomes 2, 2. This is at 3, 1, which becomes 6, 2. Is that really 6? Let me count. 1, 2, 3, 1, 2, 3. Good. This is at 1, 3, which becomes 2, 6. So I take each point and I multiply it by that dilation factor. There we go. Point by point I do this. Let's scale this by a factor of 2. Let's start with this one. This is at negative 2, 0, which is going to put it at negative 4, 0. Now, everything is going to get bigger by a factor of 2. So if this is 1, 2, 3, its new one is going to be 6. 1, 2, 3, 1, 2, 3. This is this side right here. But watch, it's also going to work if I just do the point by point thing. So if this is at 2, negative 3, the new one's going to be at, excuse me, if it's at negative 2, negative 3, it's going to be at negative 4, negative 6. Where's this? Negative 1, negative 1, which puts it at negative 2, negative 2. Here's the shape getting bigger. Where's this at? This is at 0, negative 1, which means the new one's going to be at 0, -2. This is at 2, -3, which is going to put me at 4, -6. 4. There's the new shape. Let's scale this by a factor of 2. So we're going to make this thing twice as big. Okay, where's this point? This is at 0, 2, which means 0. It's going to be at 0, 4. There's my new one right there. Now I can just build this. So I'm right, this point is right there. This is normally 1, but it's going to go to 2. So I just built the top of this thing. Let's go build the bottom of it. This is at, let's see, this is at 1, 2, 3, -1, which puts it at 6, -2. This is at -2, -1, which puts it at -4, -2, just doubling it. And from there, I've got the whole shape, don't I? Boop. There it is. Excuse me. Oh, dilate it by a 1/3. Okay, let's dilate it by a 1/3. Let's find where this point is. This is at 1, 2, 3, 1, 2, 3. So this is at 3, 3. Well, what's 1/3 of that? What's 1/3 of 3? 1. What's 1/3 of 3? 1. 1, 1. This point just became that point. This is at 1, 2, 3, 4, 5, 6. 6, 3. One third of 6 is 2. 1/3 of 3 is 1. So this is 2, 1. That's that point right there. This guy's at 3, 6, which becomes 1, 2. And this one is at -6, 3, which becomes -2, 1. So I just did it point by point. And there is the dilated shape. And that's it. Thank you for watching. Have a great day.